let's take a look at number 6 from the midterm. We have this structure here, and the question tells us the compound below, 3,3-dimethylphthalide, can react with 2 equivalents of methyl magnesium iodide to produce an interesting diol. So I've told you that the final product is a diol. And it says that this comes after workup with aqueous acid. Show the product and the mechanism for its formation. We have a little thing here. Be aware that the product just before workup is a dialkoxide magnesium salt. I really just put that there to remind you that we have to work this reaction up with acid. So twice I've told you that at the end of the reaction we have to work it up. So let's take a look at what's going to happen first with our methyl magnesium iodide. We have 2 equivalents of methyl magnesium iodide, but I'm just going to react one first. And our methyl magnesium iodide is a strong nucleophile. There's a lot of negative charge density on that methyl carbon. We can even think of it as a methyl anion and a positive magnesium iodide. But we're going to take a look or attack the most electrophilic carbon, and that is the carbonyl carbon, and we're going to promote the electrons in the carbon-oxygen double bond up onto the oxygen, and that gives us our first compound. Let's keep these consistent. So we've added a methyl group there, and we have our counter ion over there. Now I'm just going to leave these. I'm going to forget about the counter ions, and because we know they're there, we don't have to drag them along for every reaction. What can this thing do? We have another equivalent of methyl magnesium iodide around, but there's nothing there that's going to react with. However, this is our tetrahedral intermediate, and it can get rid of something by taking a lone pair of electrons on that oxygen, reforming a carbon-oxygen double bond. It's not likely that we're going to kick out a negatively charged methyl anion. However, we can easily break the carbon-oxygen bond, in which case we get this compound. So we've just broken that carbon-oxygen bond. The negative charge is now on the oxygen, and I'm not going to worry about that now. That's going to be, that negative charge is balanced by the positively charged magnesium, which is still around. But we now have another carbonyl group that has reformed, and it can react with our second equivalent of methyl magnesium iodide. Again, we're going to attack the most electrophilic carbon, which is the carbonyl carbon, and we end up with this compound. Notice now I'm going to put my magnesium iodide, and I only do this. If you didn't have this, that's going to be okay, because in the question I indicated that before workup we have a dialkoxide magnesium salt, and that's what this is. So now at this point we're done with our mechanism, simple reaction, but we have to work it up, and we're going to work it up with some weak acid and H2O, and we just protonate everything. We're not going to worry about the inorganic products. And here is the interesting diol that we talked about. We just added protons to the 2 oxygens, and we're done.